Scattered all throughout the globe, the banded iron formations, as they are known, are vital for today's economies. They are the major source of all the iron mined today. Following its oxygenation, the Earth was more recognizable. But before it would become the planet we know, a new cycle of cataclysmic events would take place. Over the next billion years, deep movements would wrench apart the crust, and life, which had just begun to make its mark, would face its toughest test yet. $1.5 billion years ago, planet Earth was almost 3 billion years old. For the first time in its history, it was beginning to resemble the planet we know. Newly arrived oxygen had turned the oceans blue, and the continents had grown to cover nearly a quarter of the surface. But their expansion was not over, and beneath the oceans, deep forces were at work, rearranging their positions. Imperceptibly, the continents were on the move. Mark McMenamin is an expert in plate tectonics, the study of continental movement. Until the 1960s, this was radical science.
In the 19th and early 20th century, the consensus view was that the continents were fixed. All geology was local, and the continents stayed in one place.
But problems for this view had been mounting. One of the greatest mysteries was the geographic position of certain fossils.
Trilobites like the one on my left here belong to the genus Paradoxides.
The Paradoxides really was a paradox. It was a freshwater creature with a curious distribution.
This trilobite is found in the eastern part of North America.
And also in Britain, on the other side of the Atlantic Ocean.
The freshwater Paradoxides could not have swum the vast salty ocean. And they were not the only fossils showing bizarre intercontinental distribution. Geologists struggled for an explanation. In 1912, a radical new theory would emerge from Greenland that would lay the foundations for plate tectonics and shake Earth science to its foundations. The new theory was put forward by a German weather scientist, Alfred Wegener, a man who had spent much of his career conducting atmospheric research in Greenland's frozen wastes. But Wegener had always been fascinated by the geologist's fossil paradox, and he boldly claimed that the answer was staring them in the face.
Ever since accurate world maps were available, school children and others have pointed out the fit between the east coast of South America and the west coast of Africa, and this was always dismissed in reputable scientific circles as just a coincidence of no meaning, and so many disappointed children were turned away and told that their idea was wrong.
Wegener proposed that the continents had indeed once been joined together and had subsequently drifted apart. His observations in Greenland convinced him this continental drift was possible.
I think that his inspiration was meteorological. Perhaps he saw a breakup of ice flows and made what we would call an extrapolation to the hard rock part of the planet.
But few geologists could accept the radical theories of a mere meteorologist.
There was complete rejection of what Wegener was saying. This is a tall order to take a gigantic continent and shove it through the ocean floor to get it halfway across the globe.
Throughout his life, Wegener fought to gain evidence for his theory. But his brave attempts eventually led to his demise. In 1930, his last expedition to Greenland ended in tragedy when he lost his way in a snowstorm.
In an icy situation on a glacier, it's difficult to find your way. Separated from both his base camp and the other members of his expedition, he basically got lost and died of exposure.
Wegener was dead, but his theory of continental drift lived on. The breakthrough came after the U.S. Navy produced a global map of the ocean floor, originally commissioned for submarine warfare during World War II. This detailed map revealed one of the Earth's greatest secrets: the fractured network of submarine mountains, volcanic rifts, and trenches that split the oceans into enormous plates of crust. These plates would be the building blocks for the new science of plate tectonics. The rifts and trenches would provide a solution to how continents drift by proving that the ocean floors are continuously being recycled.
Plate tectonics is completely driven by the destruction of the old and the creation of the new.
Deep below the surface, mobile mantle rock is in continuous circular motion, following convection currents of heat generated deep within the planet. Where these currents rise, the rifts form and the plates are pushed apart, with new ocean crust created in the gap. Where the mantle currents sink back down into the Earth, they drag old oceanic plate down with them towards the interior. As the ocean plate moves, so do the continents.
That oceanic plate drags the continent along with it. The process is like an escalator or a conveyor belt.
The process of ocean creation is visible today on a rocky island in the middle of the Atlantic, Iceland. Iceland lies on the mid-Atlantic Ridge, a 10,000-mile-long range of subsea volcanic mountains that mark one of the deep rifts in the Earth's crust.
Iceland is really like a peak of this mountain chain. It's like a huge volcano sitting on top of it.
Seismologist Paul Einarsson studies the volcanism of this remote island, volcanism that is helping to expand the Atlantic Ocean. Occasionally, an unusual type of volcanic eruption on Iceland confirms the plate tectonic process. A fissure eruption. A fissure eruption is a wall of fire. They can be 25 miles long and spew lava hundreds of feet into the air.
People fear eruptions. They respect the volcanoes.
The fissures mark the path of the deep plate boundary that is creating the Atlantic. All across the island, running from northeast to southwest, are the remains of these fissure eruptions, scarring the rocky landscape with shallow canyons. These canyons are very slowly widening Iceland. At their base, new crust is being created, pushing Europe and America apart.
So here we are located in the fissure between the two continental plates, the two crustal plates. Here on my left we have the North America plate, and on the other side we have Europe. This fissure here is in a lava flow that's only about 8,000 years old. So in 8,000 years, that's how much the two plates have moved.
The rate of continental drift averages about 2.5 centimeters per year, the rate at which fingernails typically grow.
2.5 centimeters, 1 inch per year, means that in one human lifetime, America and Europe will move just 6 feet further apart. But over millions of years, this speed of movement was enough to shift the continents thousands of miles. Using plate tectonics as their guide, geologists such as Mark McMiniman have reconstructed the epic story of continental movement from the beginning. From samples taken from present-day continental margins, they've compared fossils and microfossils and matched up distinctive types of ancient rocks to reconstruct where the continents used to be.
It's a tricky task It's kind of like Humpty Dumpty. You've got all of these pieces. You need to use whatever clues you can, whatever fingerprints you can, to put one continental margin against the other.
They are now confident that they can trace the movement of the continents back over 1 billion years to a time of a mass continental collision. As the oceans between them were swallowed up, the large land masses drew together in what was to become a supercontinent, Rodinia. It is believed that Canada and the USA formed the supercontinent's heart, with other continents bunched around them. But Rodinia was unlike any continent seen today. It was a desolate, lifeless place.
It would have been very much like being in the desert. It would have been similar to parts of the Sahara, Death Valley. There would have been no plants, no forests, no grasslands. Rodinia would have been a barren continent.
Rodinia may have been lifeless, but it was to have a profound effect on life in the oceans. In the oxygenated waters, primitive life forms were blooming alongside the stromatolites. But the huge supercontinent was about to give them a tremendous shock. Rodinia was to trigger what is now known as Snowball Earth, the biggest freeze the world has ever seen. By around 700 million years ago, Rodinia's position was blocking the currents that brought warm water from the equator to the poles. Without this heat, the polar regions froze. The resulting ice reflected more of the sun's rays away from the Earth, and in a catastrophic snowballing effect, temperatures dropped still further, and the ice advanced to cover the Earth. Surface temperatures fell below -40 degrees. The oceans were covered in an ice sheet almost a mile deep. The only life on Earth, marine bacteria and algae, were trapped beneath in the darkness. The result was disaster. All but a tiny fraction of organisms were driven to extinction. The whole planet was dying.